Welcome everyone. Today you'll be writing your first real Python programs. We'll start from the basics, what Python is and where and how to write code. Then we'll move on to the building blocks of Python, the words called the tokens, and how to store information using variables, data types, then how to format your code so that Python understands it and executes it correctly. And finally, we'll be learning how to take input from the user. Now that is very important because the ultimate aim of any program is to take instructions from the user. In the end, I'll help you write 3 small programs all by yourself. During the course of the video, I'll be showing you how to write the instructions and what type of output you will get. So just keep a notebook ready and then you can jot down new terms as we go or snippets of code. If you have any questions, then you can put it in the comments and I promise to answer. So let's dive straight in. What is Python? Python is a high-level language. All of you know that a machine understands only zeros and ones, the binary language. We cannot give our instructions in binary language because we do not know the binary language. We can give instructions in a language that is close to the language we speak, the way I am speaking to you, communicating with you. And that is a high-level language. Now, Python is a high-level language. That is, it is very close to the way we speak, the human language that we use, and hence it is easier to read and understand. And that is why beginners love it. They can just read and get a basic idea of what the instruction is trying to do. But professionals also use it for serious work like building AI models, websites, data analysis, automation tasks, and so much more. So how do we write code and execute it? There are 2 ways in which we can do that. We can use an interactive shell and we can use script. Interactive shell is a command line interface where you type one line of command, it gets executed by the operating system and the output is displayed immediately. If there is a bug in the command that you have given, the instruction you have written, then that error message will also be displayed there and then. On the other hand, the script executes the whole code at a time. Suppose you want to write 10 lines of code for a program, then the interactive shell will execute one line at a time as you go on writing. On the other hand, in a script, you write all the 10 lines of code in a place, save it, and then execute it on the command line. Interactive shell is good for quick tests. You think that this could be a right variable name. You think that this syntax is right. You think the addition operator can be used in a certain way. You want to test whether it is right or not. So use the interactive shell. But if you have to write full programs, like you want to build a calculator program, you want to take the marks of all the class and analyze who has got the highest, who has got the average marks in each subject and who is the class topper. For that you will have to write a script. And where exactly do we write code? To write a code, we need an IDE, Integrated Development Environment. That means we should be able to write a code, write somewhere, type, that is an editor, and then we should be able to execute it, like Python should be able to execute it. There are many tools available. IDLE is Integrated Development Environment, VS Code is again an Integrated Development Environment, and then you also have online editors. So let me just show you how you can download a tool like IDLE, and I'll also show you how the online editors would work. So which one should we see first? Okay, let me see online editor, online Python editor. So let me see what happens. Yeah, onlinepython.com. So here I'll just click on this. So this is online. I do not need to do anything. This is something that is already written here, and if you run, then you will see what is happening. This is a program that is being run here. Enter first number. So I'll enter 23. Now it will ask me for the second number, 78. Okay, it adds 2 numbers. So let me see if it will do my bidding. I'll just say print hello coco. Print. Okay, it has already given me the code. Hello world. The simplest program, and typically the first line of code that you will write anywhere. I've written it here. I'll run it. See, hello world. So this is an online editor. Basically, it is running a script. As you can see, I can write multiple lines of code. This program has multiple lines of code, and then we are running. So this online editor will help you write a script. But I do not want an online editor. I want something for my own system. So idle Python download. Okay, download Python. I'll click on that. Okay, download the latest version for Windows. I have Windows system, so I'll download for Windows. If you are using Mac, you will do it for Mac. So here it will be downloaded. Typically what I do is I have a software folder. I will save it. See, it has come back here. It is downloading. See, it is done now. I can just open from here, or I'll just click on the show in folder. Now it is showing me in the folder. I will click on this, install Python. I want to install, no customization. It's installing. You can see all the different parts. Libraries are very important for any program. So when you write print, for example, you did just now, you wrote print. How does Python know what to do with print function or print command? It has that already written out, that small program, that what happens when somebody gives the command print. That is already there in the library. So these libraries are very important. You can see here 64-bit. So systems are now all 64-bit, but some older systems could be 32-bit. Bit is binary digit. Anyways, I'm giving you all that extra information. You should always look very closely when any software is being downloaded, you know. So it should be done in a few minutes, seconds. Let's see how fast my system is. Okay, setup was successful. But let me go with the default. So I'll just close it, and then I will try to open IDLE. See, the app is here. I will click on this and it will open very neatly. This is the shell. Do you see this 3 greater than sign? So this tells me that this is the command prompt. So you can test it like this. Print. So it is giving me help also. Hello hello world is printed, and then the next line comes. If I click on new file, so now this is where I can write the script. When you write scripts, that is multiple lines of instructions, then you will write here and it will do. We will see how that is actually done. For now, let us just go back to the discussion that we were having. So I have shown you an online editor, and I have also shown you the interactive shell as well as the editor where you write your script. Now let's move to actually writing programs. First command is always print, which shows the output. You have already seen this, so not much to discuss here. Next is comments. So comments will start with hash, and they are notes for humans, you or someone else who is reading your program later, so they can understand what is going on in that line. Python will just skip that. It is reading the instruction, it comes to hash, and it will just ignore whatever is coming after that. So that is about print and comments. There is one another thing you should know about, and that is escape sequences. You have seen just now that whatever we put inside the quotes is printed as it is. As you can see, there are 3 escape sequences that I have listed here. /n would print a new line. /t would print a tab. And quotation mark, then it will print codes. So next time you write a program, try using them for your print command, and then you can see how the output changes. Let me tell you, clicking around your instructions, working on the idle or online editor would help you learn much faster than anything else. So this was about the print and comments command. Next, let's come to the character set and case sensitivity. Python treats letters, digits, symbols, white spaces. Letters would be lowercase and uppercase both, A to Z. Digits would be 0 to 9. Symbols would be hash, @ underscore, dash, asterisk, forward slash, backward slash, greater than, less than, ampersand. Just look at your keyboard and whatever symbols you can see there, you can use many of those in Python. Of course, different symbols have different uses. For example, you saw just now that hash is used for comments. So you will learn about them as you write more and more programs. White space can be either one single space or triple white spaces. White space is very important and we will come to that later. The next thing that you need to know is Python is case sensitive. In English, we have lowercase and uppercase. Then when you learn Microsoft Word, title case, sentence case, Python is case sensitive. Means say I write S-C-O-R-E. I write S-C-O-R-E. Then I will write capital S-C-O-R-E. I will write S-C-O-R-E. I will write small s and all the rest are capital. All these are score if you read them. But in Python, if I am using score as a name for something, then all these are 5 different names in Python. So please remember that Python is case sensitive. Now, like English has different cases, title case, uppercase, lowercase, Python also have their own names. In snake case, all the letters are lowercase, and if you want to use 2 words, for example, I want to use score and mile. So this is a snake case and I'm separating the 2 words score and mile with this underscore. Then you have something called Pascal case. In Pascal case, the first letter of each word is capitalized and there is no space or underscore. For example, I'll just write it for you, my score, right? Or if I want to continue with this score, my. So no space, no symbols, nothing. This is Pascal case. Or sometimes it is also called upper camel case. That brings us to the question, what is camel case? In camel case, the first letter is small. So it will be like my score. Let me take a longer example so that it is easier for you to understand. This is camel case or lower camel case, and this was Pascal case or upper camel case. Very simple. The first letter is uppercase or lowercase. There is one other case which is not very commonly used in Python, but you might in future learn new languages. Then you should know that is called kebab case. Let me write. We will have all letters lowercase and the words will be separated by hyphens rather than the underscore. So it will be like my dash, there's no space, even if it looks like space I'm giving. My user name. So this is kebab case. There are 4 cases we learned. Snake case, the most commonly used. Pascal case or upper camel case or lower camel case, and then finally the kebab case. There is one more, that is a screaming snake case, where all the letters are uppercase and the words are separated by underscore, right? I will write it something like SCORE_M. So this is screaming snake case. Okay, so this was about Python being case sensitive. White spaces are very important for indentation, and indentation is not a matter of choice. I hope you remember what is indentation. Let me just show you in case you have forgotten. In English, when you write paragraphs, you will write one paragraph from here. So this is the left margin. You will start writing from here. You have written, and then when you want to start the next paragraph, then you start from here and the next line will go. So this horizontal distance that you give from the margin is called indentation. In Python, it is required to differentiate between different set of instructions. We will get to it later when we are doing decision making or loop, that is if else. But for now, just remember that white spaces are important for giving indentation in a Python program, and indentation are very critical for a program running correctly. Now let's talk about tokens. Tokens are something like you have words in English. They are one of the most important building blocks of Python. Keywords are the most important tokens because they are reserved words that are already used by Python for something. For example, print. That is a command, that is a reserved word, and you cannot use it for anything else. Then the next set of tokens is identifiers. Identifiers are names that you create for variables, constants, functions, class names. So many things are there which you will learn later. Anything that you want to name in Python, you have to create a name for it, and that is called an identifier. Identifiers are also tokens. Next are literals, the constant values. You define them once and the value remains the same throughout. It could be numbers, string, and numbers could be like integers or decimal numbers. Decimal numbers are called float in Python or rather any programming language. So literals are another set of tokens that you have. Then you have operators. Operators do work like addition or comparison. There are many types of operators, like operators for doing mathematical calculations, logical operators for doing stuff like comparison, comparing equal to, greater than, less than. We will be studying about these operators in detail as we come across them while writing programs. There is no point discussing just the theory here. I just want you to know that operators are also tokens. So there are 4 types of tokens that I have talked about today: keywords, identifiers, literals, and of course operators. Now to start writing a program, you first need to learn how to create identifiers. There are some naming conventions that you need to follow. The first one is the identifier name must start with letters or underscore. It cannot start with a digit or a special symbol. Only letters or underscore are allowed. Next is what I said, cannot start with a digit. Then keywords cannot be variable names. That means a keyword cannot be used as an identifier. Why? Because that token, that name has already been reserved by Python to mean something. Then this is not a convention, but this is, you can say, a tip for good programming practice. Use self-explanatory names like total underscore marks, student underscore name. Total underscore marks is better than using identifier like TM, or instead of student name you are using SN or ST. Because what happens is once you write the code, that stays forever. Today you have written a code and then you come back to visit it after say 3 months. If you have cryptic identifier names like PM, SN, FT, PQ, will you be able to identify what they actually mean? You are writing programs that are maybe just 10, 20, 30, 40, 50 lines. When you talk of large programs, then they have thousands and thousands, millions of lines of code. So obviously even the person who has written them will not be able to recall what that cryptic identifier name meant. That is why it is better to use self-explanatory names. You already know keywords have been created by Python. You know how to create identifier names. So let us come to literals. Literals are numbers, string, boolean. Integers are whole numbers. They could be negative or positive. One interesting thing is that you can use underscore inside big integers, something like we use comma. Python will ignore them. But if you are using it for large numbers, then it will be easier for you to read. Let me show you how this underscore does not make any difference. So what I'll do is I'll write here a equal to 1 underscore 000, then print a. See, it has read it as 1000, right? So this is what I was telling you, that integers you use underscore, but Python will ignore it. Next is float. Float is decimal numbers. 3.14, 17.286. Those are floats. The other one here that I have shown is 4e3. So e means exponential or to the power of 10, 10 to the power of whatever number comes after e. So 4e3 is actually 4 into 10 to the power of 3. We have strings, so strings can use double or single quotes or even triple quotes for multi-line text. Booleans are true, false, or not. These are all Boolean values. Let me show you some of the literals that we have talked about. A equals 1 underscore 000. Let's now see what all are printed. So that was about literals. Now let's come to operators. Those tokens that actually do things. The first one is arithmetic operator, plus, minus, star, then you have float division, remainder, and double asterisk is power. Then we have comparison operators which return true or false. So they will use these operators equal to, not equal to, greater than, less than, greater than equal to, or less than equal to. They will use these to compare two expressions or two numbers, two values, and return a value true or false. And based on that, the next step of the program or the next instructions will be executed. So here I have given the command and the answer as well. You can try them yourselves and let me show these to you as well. Now, whenever you talk about operators, then the precedence is very important. Which operator comes before what? It is same as what is done in mathematics. Double star or double asterisk comes first to the power of, then you have the various divisions, then plus, minus, and comparisons are the last to come. But actually, when you are in doubt, then it is easier to add parentheses. It helps both Python and the people who are reading your code to read it correctly, understand the meaning or understand the sequence of execution correctly. In fact, I would advise, as someone who has been doing programming for decades, that you should develop the habit of using parentheses for clarity rather than relying on the operator precedence to write one long line of expression where there is no parenthesis, only numbers and operators. Here again, I have given some examples. You can try to execute them on your own. You can use the interactive shell to print the value of each line of code. Now let's talk about variables. Till now we have been working with numbers. We are using fixed integers. But that is not always the case. We sometimes need to work with variables whose values are unknown. You are in class 8, so you have already done algebra. So values x, value y, and then you solve the problem and then you come to the value of x and y, the actual value. Similarly, you can think of variables as that x or that y whose value you do not know, but you know that entity is there. That entity could be an integer, it could be a whole number, it could be a string, it could be float, but you know that that variable is there. In terms of programming, you can imagine variables as labeled boxes. You can put a value in those labeled boxes. The box has a label, whatever variable name that you create using the variable naming conventions that we discussed earlier, and you can change the value, you can change what you have put inside that labeled box. So that is what variable is. Python has dynamically typed variables. That means you do not need to declare the type of the variable before assigning it a value. There are lots of programming languages like C and C++ where you have to statically declare that, okay, this variable x would be an integer, this variable y would be always a float. So the type is declared beforehand. But in Python, you just say x is equal to 2, that means x is a variable and it has value integer, or number is equal to 47.5. So number is a variable and it has the type float. The type depends upon what value you are storing. That is why it is said that Python is a dynamically typed. Swapping is, really an elegant Python trick where you do something like this. X, y, you have defined it. So x is 5, y is 7. But then you say x, y is equal to y, x, and the values will be swapped. This is very unique to Python. So this is something that I just wanted you to know. You can do this x, y, 5, 7, do the swap, and then try to print the values of x and y, and then you can see what is happening. Let me just show you how that happens. So let me do the swapping program for you. X, y equals, let's give some random number, 17, 23. Print x, y. Okay, so x is 17 and y is 23. Now what I'll do is x, y is equal to y, x. I can give some space also here for clarity. Okay, and now let me see what happens. Print x, y, 23 and 17. So the values have been swapped. So we have been talking about integer and decimal values. Let us discuss the core data types that are there in Python. There are 4 data types that you use most frequently. There are more, but you don't need to know them right now. Integer, float, string, and boolean. Integer is whole numbers, float is decimal numbers, string is text, combination of text and number. So if it is num3, number2 or student, then that is a string. And Boolean is of course true and false. So these are the core data types. You can check the type of data with the type command. So it's like a detective. Know that the output of an operation depends upon the data type. Variables are constants on which the operation will be performed. They are the operands. Like we are using plus. So addition on numbers is math, but addition on strings will simply join those texts, like I'm showing you here. Till now, whatever operations we have been doing has been using numbers. When it comes to strings, let us look at a few basic operators that you will be using very frequently. Concatenate is joining two or more strings with plus sign. Then you can repeat with asterisk sign. And you can find the length of the string with len. You can also break down one text into two or more parts. That is called slicing. So let me just show you how all these work. So it has given no space between hello and Shweta. That means I need to give one space, right? Then I will say plus name and then let's see what happens. Okay, so now that space is there. So what does asterisk do? It repeats the string within. If we had given a space after HA, then with the space it could have been printed. Now let us check the LEM. Six letters are there in my name. So it has counted question mark and spaces as well. Name 0. So the first alphabet of the name. The numbering always starts with 0, right? Not with 1. SE. It automatically gives a space. Now let's talk about something called type conversion. Type, data type. Conversion from one type to another. It is very critical when you are working with inputs, because when you input something from the keyboard, then Python always gives you a string even if you have typed the number. So if you want to do mathematical operations on those numbers, you will have to convert before doing your maths. If you forget, then 2 plus 3 would become 23, because when it was inputted, then it became 2 and 3. Something like this. So A is 10 here, B is 20. When you print A plus B, then it becomes 1020. But if you do print int A plus int B, then it becomes 30. So let me just show you. Now you can understand the next two lines of code that I have written here. Int, whatever input I am taking, convert it to integer. Whatever input I am taking in the second line, that has to be converted to float. And then you will write print x plus y and the addition will be displayed. Till now, I have taught you lots of basics about printing, commenting, and what are the data types, and what are the mathematical operators, what are operators we can use on string and integers. So it's now time that you should write a program of your own. Very small program, take marks of two subjects and find its total, average and percentage. I want all of you to pause the video right now, go to Python, write the program, and then come back here and look at the solution that I'm going to show you just in a second. This is my solution, but I guess it will not make much sense because you are used to writing in the interactive shell, and now I want you to start using the script. Let me open the Python editor. Great, this has opened the interactive shell, but what I want is to open a new file. And this is somewhere I can write the script. Now I have the script pasted because it will take me lots of time to do this. So this is the program. The only difference that you would find is in the print command. It's a really long print command, as you can see, and there is something new that I have used here. You can see I have put the variable that I want to print in curly brackets. But you know that whatever is put inside the quotation marks is printed as it is, but I want the value of the variable printed. That is why I have put the variable names within these curly braces: name, total, average, percentage, and I have put a F before the quotation mark to instruct Python that whatever comes within the curly braces, its value, convert it to string, and then print it. In fact, I think I will show you what happens here if I do not put a F. I will not put the F here. I've removed it. I have both the guys, so there's nothing better than showing the proof. One other thing that I have done here is I have put here 0.2F. Okay, that means that this float number should have value 2 places of decimal. Now here you are dividing by 2, so any number would have only 1 place of decimal. But if you have a number, a float number, where the number of places of decimals is 8 or 10, the whole decimal would be printed. Since I am giving 2 places of decimal, so you will see what happens in the result. So this is the program. Now I will run it. Actually, I should save it first, but I'll show you what will happen. See. Source must be saved. Okay to save, very much okay to save, but then for saving I have to give it a name. Do not try to change the folder. Just give it a name. Marks sum average. Okay, I have saved it, pressed enter. See, now the shell is here, interactive shell. Read marks calculator, give your name. Okay, I will give my name, Shweta. Maths marks 78, 89. See what has happened here. The first one, F I had given, so now it has converted the variable names into their values. Hello Shweta, total is this, average is this. The answer was 83.5, but I wanted two places of decimal, so 0 has been added, like in maths. Percentage 83.5%. I did not give F, so it has printed it as it is. Okay, so now you understand why we need to give F. Now I will close it and will move to our discussion. So this was the mini program 1. I have more programs for you. Read two numbers and print the sum, difference, product and quotient. The calculator program. I will give you the solution also, but I want you to do it yourself. You can pause it, note it down and then write it. I don't mind, but please do it. Here you can see I have not added these calculations as different lines of code. I have done it within print. Why add extra lines of code? Temperature converter, take a Celsius temperature from the user and convert it to Fahrenheit and vice versa. Celsius to Fahrenheit, Fahrenheit to Celsius. So you can try your city's average temperature. Just Google it, any city you like, take its average temperature and just do it. This is the solution again. So you have learned about the print command, how to use operators, how to create variable names, how to use string, how to use the string operators. You have learned about the core data types and also how the input needs to be converted when you take the input from keyboard. This is all video. In the next video, we are going to talk about decision making in Python. Till then, I want you to keep practicing the programs I have shown. Pick up your book, practice the programs there. And if you get stuck somewhere, drop a comment. I promise to answer. If I have to write the whole program for you, I will do that. Better still, paste the program that is giving error and then I'll debug it for you and tell you what the correct code would be. If you like this video, thumbs up please. If you think someone will benefit by this video, please share it with them. Subscribe to my channel because I'm going to share lots of videos on artificial intelligence as well as Python. And please don't forget to press the bell icon so that you get to know as soon as I upload the next video. That's all for today. Thank you. Bye-bye.